So let's justify that the sine and cosine of pi over 4 are actually both square root of 2 over 2, and why we write it that way. So again, I can't emphasize enough the power of drawing pictures to solve trigonometry problems. So what I'm concerning myself right now is the claim that the cosine of pi over 4 is equal to the sine of pi over 4, which happens to be the square root of 2 over 2. So all I need to do that is the first quadrant, quarter circle, that wasn't too bad, and then draw my best pi over 4, which is a 45-degree angle. So right there is my pi over 4. Now, since that's pi over 4, 45-degree angle, I turn that into a triangle by dropping a perpendicular here. So there's my right angle. And then I check out this length here too, so the x value. So on this triangle, what kinds of things do I know? Well, remember, inside of a triangle, interior angles the interior angle sum in a triangle has to be 180 degrees. 180 degrees is the same as pi radians. I know that this is a right angle, so that means this angle right here must be 90 degrees or pi over 2. Right? We got to get used to thinking in radians, and sometimes we'll use degrees to push us that way. So that means these two angles right here, if that one's pi over 4 or 45 degrees, this one we have to figure out what it is. So from pi, if I take away pi over 2, that leaves pi over 2. From that remaining pi over 2 that these two angles have to share, one of them is pi over 4. Pi over 2 minus pi over 4. Well, pi over 2 is really double the top and bottom, 2 pi over 4. So that's also pi over 4, or 45 degrees. So I know this angle right here is pi over 4 also. So with the symmetry in this triangle I have right now, this is an isosceles triangle because I have two congruent angles, pi over 4 and pi over 4. So that means the sides opposite those angles have to be equal also. So whatever this is right here, this has to be the same thing. Another way to think about this, this is a 45-degree angle here, a pi over 4 radian angle. This right here is the line y equals x. Right? Y has to be the same as x. So if I call this side x here, then I have to call that side x also. Putting that all together with the Pythagorean theorem and that this is the unit circle, radius equals to 1, I get x squared plus x squared equals 1. That gives me 2 x squareds is 1. Dividing by 2, I get x squared is 1/2. So then x has to be plus or minus the square root of 1/2. Now, since I'm in quadrant 1 here, I would choose the positive version, but if I was in a different quadrant, I would choose the negative, right? And it depends on whether it's x or y. So I'm just going to say this is the square root of 1/2 for my use. Now, that is one possible answer. I could just say, hey, this point right there is the point square root of 1/2. Comma, square root of 1/2, because x and y have to be the same. I'm going to clean that up a little bit because I can take the square root of 1. So this would be the square root of 1 over the square root of 2. Square root of 1 is just 1. So this is 1 over the square root of 2. So that would be another acceptable thing here. Right? I could say that the cosine x of the angle pi over 4 is 1 over the square root of 2. And I can get a calculator to agree with me on that. Now, it's fashionable in mathematics to rationalize the denominator, meaning get the square root out of the denominator. And if we do rationalize the denominator, the trick there, think back to your previous math classes, to multiply by that same square root top and bottom. Square root of 2 times the square root of 2 simplifies down to just a plain old 2. 1 times the square root of 2 is the square root of 2. So I have at least 3 names for this particular number. I could call it the square root of 1/2, like I found right here. I could call it 1 over the square root of 2, like I did there. Most common exact value for this is the square root of 2 over 2, but they're all the same number. but you will see the square root of 2 over 2 more often than you see either this version or that version of the number. Let's whip out a calculator and check. How about we use my scientific, there we go. So the first version I found was the square root of 1 divided by 2 inside the roots. Calculator says that's 0.707. Second version I found of that was 1 divided by the square root of 2. Calculator says, yeah, that's 0.707. And then the last version I found of that was the square root of 2, get outside of the root, and then divide by 2. And that's 0.707. So again, this last one is the most common one you'll see in books, in videos referencing trig problems with a reference angle of pi over 4. But there are other ways to write that down exactly. Which is the best way? Well, I don't know. I'm not a huge fan of rationalizing the denominator. I just talk about this one because it's common. I kind of like this one right here. It uses slightly less ink than that one down there. And I think it uses slightly less ink. If we were to weigh these three, I bet this one weighs the least in terms of ink. And a lot of times in math, I think about the simplest answer is the one that uses the least ink. I don't know. Okay, that's a little math philosophy. These are all the same number, right? Down to what, 10, 12 decimal places there. We need to be familiar with it. Moving on.